Have a parametric function. X is sine of t and y is cosine squared. We're supposed to set up the integral for the arc length. Well, for arc length, if it was just y equals a function of x, then arc length would be integrate 1 plus the derivative squared dx. And then you've got some range of values for x from a to b. Well, we don't have just y equals a function of x. We have x is a function of t and y is a function of t. So in here we're going to need both of those derivatives and then squared and added together. We're also going to need to know what is the interval. Since these are trig functions, I have a feeling it's going to be from 0 to 2 pi, but there's times when you think it's 0 to 2 pi, and 0 to 2 pi actually makes the graph twice or 3 times, just because of the nature of the functions, especially with something like this. So graph it, sine of t for the x value, y is cosine of 2t squared. Start by going from 0 to 2 pi. Since these range between -1 and 1, I can keep my x and y values ranging from -1 to 1. I'm going to change this back to the 0.13 default. And the graph is a W. Now, if you go from 0 to 2 pi, that does graph the whole thing. But what if we went from 0 to just 1 pi? Would that graph the whole thing? Well, that would be half of it. So you might think, hey, why don't we just integrate from 0 to pi? Because this thing is symmetric, the length on the left is the same as the length on the right, so you could just find out that length, then double the answer. Sounds good, but there's one small problem. When you graph it from 0 to pi, and let me slow it down, and also I'm going to change this. Yes, now watch the graph. So it's going to graph, and right there it gets to the top. It then stops and goes back. So if we were to integrate from 0 to pi, that would be double the answer. So it really should be from 0 to pi divided by 2 that will graph it just once. Let's see. There's pi over 2, and it stops. Okay, so we should be graphing from 0 to pi over 2, and that's one side of it. And then, to get the left side of it, double the answer. Now we need this idea, but we have two derivatives. So we're going to have the square root of, take the derivative of sine is cosine, and then square it. Then we need the derivative over here, so the derivative of this is going to be the 2 gets brought down in front, and then it's cosine of 2t. Then you have to take the derivative of cosine. That will be negative sine of 2t. And then the derivative of the 2t is a 2. So let's say I close the parentheses for that negative sign. I need to close the parenthesis here, and then square it, and then make a much bigger square root. And then it's going to be integrated with respect to t. Well, thank goodness the directions just say set up the integral. That would be a pretty tough one. Okay, then convert it to rectangular form. Well, let's see. When we're looking at the graph, this right here, the whole graph of a W I've never seen outside of parametric equations, but this sort of looks like a parabola. So I'm wondering if it isn't something that has y equals x squared. Sometimes that's a helpful idea, sometimes, especially when it's a graph that you haven't seen before, like this W, sometimes looking at the graph doesn't help you convert. Let's see. with eliminating these, so we're supposed to eliminate the sine and the cosine, eliminate the t, we need something like sine squared plus cosine squared equals 1. Now that doesn't say cosine squared of a 2t and sine squared of a 1t can be added together and equals 1. The argument has to be the same. So we need a trig identity to replace cosine squared. So there's 3 to choose from. The one that I'm going to use is that cosine squared of a 2t is 1 minus 2 sine squared of just a t. So a double angle formula. So we've got y is equal to, so replace it with 1 minus 2 sine squared. And then from this one, the sine can be replaced with x. So we'd have y is equal to 1 minus 2, and then sine squared, so that would be x squared. And the parameter has been eliminated, so we're done.